Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and DataSet. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I need to cover just a couple of housekeeping notes. So today's session is being recorded. If you miss any of our discussion, or maybe you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. Now, on the right side of your screen is where you'll also find a chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you're joining us. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So our topic today is scaling Kubernetes with DataSet and AWS. And I'm joined by Amit Sharma, product leader at DataSet, Dave Parker, manager of site reliability engineering at DataSet, and Josh Dean, senior solutions architect from Amazon Web Services. So Amit, Dave, and Josh, thank you all so much for joining me. Amit, would you like to take it from here?
Yeah, thank you, Cody. Everybody, appreciate you joining us. Thank you for making us part of your day. So real quick introduction. My name is Amit Sharma. I do I'm part of the product team at Channel 1 DataSet. Before DataSet, I was at Splunk, and before that at SignalFX and AppDynamics. So I have been in this monitoring observability space for quite some time now, and have been involved with Kubernetes project, and now is an amazing community that we have since 2016. So I have done Kubernetes networking, but mostly I have been involved in Kubernetes observability with different companies. But majority of my career has been as a software engineer. Dave, do you want to introduce yourself?
Yeah. So my name is Dave Parker. I've been in the industry. It's funny. It's long enough now. I don't actually even know how many years it's been. But I've been working with Kubernetes since about 2018 at varying scales from small to now extremely large, multiple production clusters and thousands of instances. It's been an interesting journey. It's a lot of fun, so I'm the site reliability engineering manager here at DataSet.
Awesome. And we are delighted to have Josh with us. Josh, do you want to introduce yourself?
Sure, yeah. My name is Josh Dean. So I am a senior partner solutions architect at AWS. And so what that means is I get to work with awesome partners, help them build and sell technology that really expands what AWS does. I've been at AWS now for almost 6 years, which feels like forever. Before that was working with some other cloud providers, smaller cloud providers, everything from data center up through application networking, things like that. So, nice to be here. Looking forward to it.
Thank you, Josh. All right, so let's dig in. So we're going to talk about scaling Kubernetes. What are the challenges? First of all, what do we mean by scaling Kubernetes? It'll mean different things to different people. So you might be thinking, hey, scaling Kubernetes is a number of nodes in my cluster, right? I started as 5 nodes, 10 nodes, 100 nodes. Started as really a small cluster with 2-3 nodes, right, in my dev and test. And as we go to production, that number increases. Number of clusters is another way to think about scalability in Kubernetes. People would also say, how many pods are I'm deploying in per node, right? That's a scalability challenge. That's a scalability issue. Or containers or workloads I'm running, how many stateful workloads I'm running, that's a scalability issue. How many developers I have using my cluster, how can I give access to certain part of my cluster using role-based access control for my developers. So scaling developers accessing clusters, right? There are so many aspects of scalability in Kubernetes. So in this webinar, we're going to have a lens on all these things that we'll talk about, but also looking from monitoring, logging, and observability side. How can we scale that? How can we roll out to everybody in our teams across the organization? So scaling Kubernetes is difficult. We'll talk about challenges. How do we do Kubernetes the easy way? So we'll talk about different implementations of Kubernetes and what does Amazon Web Services have to offer to running containers in production. Dave will talk about his best practices, things that he has seen scaling, running DataSet on Kubernetes, on Amazon EKS. So he'll share those lessons from the trenches. We'll talk about DataSet and Kubernetes Explorer, how that can help you expedite troubleshooting and monitoring the entirety of the cluster. We'll have a live demo and a Q&A. We'll have a lot of time towards the end for Q&A. So let's start. So just setting up the context, why our customers and why you are running containers. So this is like something that you are already doing, something that you would know. But the first one, the reducing risk, is less intuitive. After all, virtual machines have a very good isolation. So how is containers within Kubernetes provides less risk? Kubernetes also has the similar constructs of firewall and security and network policies that will give you isolation between workloads, pods, namespace, so that you can run different workloads with isolation within Kubernetes. Operational efficiency, we know that it's a self-healing, immutable infrastructure. So if a pod dies down, Kubernetes will recreate it. If a node is running out of resources, Kubernetes will add a node if you have set auto-scaling. So these sort of things that automatically the platform is going to handle, so your DevOps teams are more productive, they are efficient. Plus the bin packing, right? The number of pods. So companies run hundreds of pods per bigger nodes, right? So better resource utilization. So higher density of your workloads within infrastructure gives better utilization and hence the cost optimization. Kubernetes provides us a way to standardize the provisioning services. So it's a portability, right? So it increases the speed of delivery of new features, applications. It standardizes the delivery of software. So it gives increases the speed and increases the agility. So what are the challenges in operationalizing Kubernetes? So CNCF did this survey. It's the latest survey that they have published from last KubeCon. The number one challenge in operationalizing Kubernetes is logging and monitoring. How do I know whether I have an issue in my cluster? How do I get granular logs easily, fast, and how can it scale? Because we're going to see in the next slide, Kubernetes creates a lot of volume of data. And complexity. Kubernetes, like any other distributed system, there are so many components, so many parts for the system. So complexity in running Kubernetes clusters at scale. And finally, the security. So I have so many components. How do I ensure the security of my the entire stack on which my Kubernetes implementation is running? So why is scalability challenging? First, it's just a data volume I talked about. It's a distributed system. Data, so east-west, amazingly high volume of east-west traffic. Can your traditional system handle the increased volume or high volume of data that is coming in the system? Fragmented data. So to make sense of it, you have different data types, metrics, logs, traces. So different monitoring and logging solution. You might have some separate monitoring logging solution for other components within your organization. How do you correlate between all these things? I talked about number of people within the organization who need some sort of access for visibility to the cluster. Now, RBAC, natively doing RBAC within Kubernetes is cumbersome, is difficult to scale. So how do I ensure that all my developers and DevOps team have access within the boundary, within the guardrails guided by the RBAC? And finally, it is expensive, right? As all this data is coming in, traditional solutions is just going to increase the cost for ingesting all that data that is coming through Kubernetes system. And here is an example of why scalability is a challenge and why just running Kubernetes at scale can be a challenge. So just if you run kubectl, run a pod, or just creating one pod might create 50, 60 different components on the backend, right, on Kubernetes system. So you might have to create secrets, different namespaces, ingress controllers, load balancers, right? So you are looking at backend services, the workloads that you have deployed. So all these parts, those workloads may require a persistent storage. So just for creating one simple pod, you may end up creating so many Kubernetes components. So getting started is easier. It's not, and this is DIY, right? So everybody might have done this yourself. Kubernetes the hard way. This is Kelsey. He created a guide of starting Kubernetes cluster using native upstream Kubernetes using kubeadm, and he has a step-by-step guidance on how to create a Kubernetes cluster. So that you will go through like in 30 minutes or so. So that is easy, but scaling running that in production is challenging because you have day two operations, right? You have to manage those components, manage infrastructure. You have to make sure that you are, there is a disaster recovery plan for your etcd. There's encrypting, securing, high availability, right? If you are managing your API server, you have multiple API server for high availability. Then how do you ensure that the state is being consistent? Security patches, backup, and disaster recovery I talked about, right? So day two operations, once you start doing in production, then it is challenging. So running Kubernetes in DIY mode, just running yourself, can be relatively straightforward. But when you start doing it at scale in production stuff, so how do you scale just the Kubernetes cluster and implementation? So doing the easy way. So I know a company that knows a thing or two about scalability, and that is Amazon Web Services. So let me invite Josh to talk about different ways to run containers and specifically about EKS within AWS. Josh?
Yeah, thank you, Emmett. So just to kind of start off, the choice really of orchestrator that you choose is super important. And it ends up being kind of the key integration point and really influences kind of the rest of the choices you make along the way. There's a lot of opinions out there, and a lot goes into it, right? One of the most common requests that we as solution architects at AWS here is, help me decide which container service to use. So we generally then recommend that most teams start by selecting the solution with the attributes most aligned to their application requirements or even operational preferences and kind of taking it from there, to be honest. So as you can see on the screen, and as you probably know if you've worked with containers on AWS, we have a choice of fully managed container services. So kind of the beast that started it all is ECS or Elastic Container Service if you're kind of more Docker focused. And then we also have EKS or Elastic Kubernetes Service. So both of these services are fully managed to support a broad array of compute options. They deeply integrate with other AWS services and provide that global scale and reliability that you've come to expect from AWS, like Emmett was saying. For the purpose of this session, though, since we're here to talk about Kubernetes, we're going to focus on EKS. And if you could advance the slide, that would be fantastic. So what we found is teams generally choose Kubernetes for the vibrant ecosystem the community, the open source APIs, broad flexibility. And they rely on EKS, Amazon EKS specifically, to handle the undifferentiated heavy lifting and of security and kind of operating Kubernetes at scale. So EKS provides the flexibility of Kubernetes with the security and resiliency of being an AWS managed service. And it's optimized for customers building highly available shared services, especially those based on open source. So just to name a couple of customers that use EKS use Amazon EKS, Intel, Snap, Intuit, GoDaddy, those are just to name a few. They trust EKS to run their most sensitive and mission critical applications. And then, customers adopting Kubernetes that want the open flexibility really should start with EKS. And then, flexibility is important. We recognize that you might not be starting from scratch when you build on AWS container services, right? You may have already chosen Kubernetes as the core and, have existing tooling and such. EKS gives you the ability to bring those services that you want and build it in a flexible environment. And of course, if you want to use EKS with all of the AWS services, you can do that too. We've been prioritizing, and you'll see that kind of continues to prioritize Kubernetes-friendly integrations with innovations like the acronym ACK or AWS controllers for Kubernetes. I'm an old networking guy, so ACK will always be an acknowledgement for me. So I'll go with that. All right, if you could run on to the next slide there. So both ECS and EKS that we've been focusing on here manage how you run containers, but you still have to have kind of the underlying compute layer. And so AWS gives you a range of integrated compute options for where that compute is happening, right? So you can choose the right tool for the job, get the right kind of combination of cost, performance, features, availability, all of that kind of good stuff. So on both EKS and ECS, you have the following options at the moment. The first one over to the left there is Fargate. So that's a serverless compute engine for containers. So you only pay for the resources that are required to run the containers. Suited for those customers that don't want to worry about managing servers, handling capacity, figuring out how to isolate container workloads for security, that kind of thing. You can also kind of think of it as like Lambda for containers, serverless, no infrastructure to run there. Next there is EC2. It offers the widest choice of instance type, including different processors, storage, networking. Really ideal for customers who want to manage or customize the underlying compute environment, the host operating systems, and so on. And then you see there a little tip to Spot instances. If you want to save on some cost, then you can also use Spot with EKS and ECS. There's also for on-premise, we're kind of skipping over. We're going all the way to the right, but you can run your containers using AWS infrastructure on-premise for that kind of consistent hybrid experience. So if you have kind of local data locality requirements or hybrid use cases, that's where running EKS on outposts or even EKS or ECS anywhere can run on-premise. And then just finally on this point, an extension of an AWS region is a local zone. I don't know if you've come across those, but they're kind of like AWS managed outposts in a way. So those are really suited for customers who need to place resources in multiple locations closer to end users. They're kind of like a mini region. So if you need to get close to your customers and there isn't an AWS, full-blown AWS region right there, a local zone is a good thing to take a look at, and they're adding those all the time. And then there's also AWS Wavelength, which is ultra low latency mobile edge computing, right? So generally aimed at 5G applications, those interactive and immersive experiences. and things like connected vehicles where you need low latency 5G connections to run them. So just to kind of dig in a little bit on EKS Anywhere, this provides support for where AWS has supported simplified Kubernetes cluster installation. It's installable software package, right? So you can kind of just take it from anywhere, run it on your own hardware. It creates the clusters for operating Kubernetes on premise and the tooling to provide that full lifecycle support. EKS Anywhere also uses the EKS distro, which is the same Kubernetes distribution that is deployed by Amazon EKS in region, allowing customers to easily create clusters kind of consistently across platforms for the best EKS experiences. So now customers can eliminate the fragmented collection of vendor support agreements and tools that they use to install Kubernetes clusters or even operate them, irrespective of where the applications need to be deployed. So EKS Anywhere provides customers with automation, tooling that's been optimized for the environment. It simplifies Kubernetes cluster installation with default configurations for operating systems, container registries, logging, monitoring, networking, and storage, and so on. So it gives the customer a full-blown Kubernetes environment on-premise that's easy to support and avoid challenges of kind of integrating Kubernetes with existing infrastructure, keeping all the open source software up to date, maintaining that business continuity with cluster backups and recovery as well. So that's EKS Anywhere. That's EKS. And with that, I believe, Dave, over to you to talk about some lessons from the trenches here.
Absolutely. Thank you for the intro there. So one of the things we're going to talk about, if you go to the next slide, is enabling audit logging. So this is one of those things that is easy to miss when provisioning a new cluster, but is absolutely critical to reason about the state of the distributed system that is Kubernetes. So you need audit logging for security and troubleshooting purposes. It provides a chronological set of records for all of the interactions that happen with the API server. So, I mean, the Kubernetes API server, everything is API based. So users, applications, automated jobs, everything interacts with the by APIs. And so enabling audit logging allows us to actually see and reason about those interactions. We leverage EKS for our workloads. So, we enable this logging in EKS and then import these logs into DataSet to troubleshoot and monitor our own infrastructure. So cool. The audit log, what is it going to tell us, right? As I said, it will highlight all of the interactions that happen with the API server, but what does that really mean, kind of a boots on the ground level? It'll help you answer questions like who is trying to access these resources without proper authorization, potentially indicating a misconfiguration around that authorization, or even bad actors who are being stopped in some way. When did these interactions happen? Who or what deleted a pod and when? And why is this workload scaling up or down or out or any direction? What is the initiating trigger for that sort of event? So the audit log will help operators of Kubernetes platforms identify answers to each of these questions. Next slide. So regarding kind of best practices around configuring the audit log. So the way the audit log is enabled is there's a rules policy that's passed to the Kube API server using the -- audit policy flag, and so that needs to be specifically configured to enable particulars around the audit logging. Specifically, in general, we want to ignore the request receive stage to minimize noise in the audit logs, make sure that we're not capturing anything that is not useful in actual day-to-day use. As a general rule, configure rules to capture logs at the metadata level. It is just, more appropriate level of verbosity. However, there are some specific requests, specifically around like critical resources and the verbs, where we want to use the request response level, which is, you can think of that as kind of like debug level interactions, where this logs the entire payload and gives you much deeper insight into the actual interaction on that API call. Of course, the downside of this is that the entire payload is actually captured. So you need to be sure to add any role-based access to those audit logs. Potentially sending those logs to a different, InfoSec policy or team, as I said, like within the DataSet product or otherwise. Next slide. Cool. So now we'll go into a couple of common errors that if you've used Kubernetes in any fashion, you will either have run into or will run into shortly. It's almost guaranteed. So one of those is the crash loop backoff error. What is that? Crash loop backoff is the error message that occurs when a pod starts, crashes, and then due to the reconciling nature of Kubernetes, gets rescheduled, tries to start and stop, and just continues to crash. These pods or containers, as they are restarted, they are restarted at an increasingly exponential backoff delay. So as stated on the slides, 10, 20, 40 seconds, up to 5 minutes delay between those effectively like crashes and restarts. And these errors are sometimes pretty tricky to troubleshoot. There's not any like specific guidance as to what causes it. Sometimes it's a matter of the application is runs out of memory. There's a memory leak, and so it's killed either by the kubelet or the node level, depending on where that resource contention is. Sometimes there's a matter of a failed or misconfigured init container that is used to pass in some secret to a config map and some initialization logic that silently fails, and then the resulting workload fails to start correctly. Occasionally, there are application initialization logic problems, a bad build or an external dependency may be misconfigured or not running. The best way to troubleshoot these is to collect the application logs to see where the crash is occurring, collect the probe logs to see how often and when the readiness and liveness probes may be failing on the workload. Next slide. So another class of errors that we'll run into is the failed scheduling errors. This happens when the Kubernetes scheduler tries to schedule a pod and it can't find, based on the configuration of the workload, it can't find any appropriate node to schedule that workload to. This is one of the cases where having a GitOps workflow helps reason about what workload specifications have been passed to the Kubernetes API server, because you can see declaratively what the specifications are in your Git repo. A couple of common causes for this failure mode are scheduling workloads with too high with requests that are too high. Remember, there are node reservations for system workloads like Kubelet. So just because, for example, a node has 8 full CPU doesn't mean that a pod with 8 CPU requests will actually get scheduled onto that node successfully. That will in fact fail because of the node level reservations for system workloads. Also, you need to make sure that any workloads have any tolerations added to nodes that have been tainted to ensure that the pods get scheduled. And kind of in general, try not to make workload scheduling rules that are too strict around resource requests, workload affinities, anti-affinities, and node tolerations and taints. If you add too much complexity into that scheduling evaluation rules, you can sometimes back yourself into a corner with conflicting rules. Next slide. So here, image pull back off. Inevitably, this is one of the ones that you will definitely see when you scale up a cluster from day 0 to day 1 to day 2. Image pull back off occurs when a pod fails to start because the kubelet wasn't actually able to find or pull the container image. One of the most common causes for this is actually running into the limits of the upstream image repository or registry. So if you're just using public Docker Hub, you'll run into limits as you scale up, or if you're using an self-hosted or personal registry, if that specific resource is having some scalability contention problems on its own, then of course your production workload is not going to be able to pull the images from there. So we sidestep this entire class of problems by using ECR, Amazon Hosted Service, Elastic Container Registry, which leverages the scalability of the AWS infrastructure underneath. One of the other suggestions here is on a per container workload, setting the image pull policy to, if not present, leverages the node local image cache, which is really useful for, again, if there are reusable images on your workloads like init containers. If you have the same init container for a number of different workloads, instead of making a separate external API call for every init container, we'll just leverage the node local cache there. Next slide. So, troubleshooting Kubernetes services. Services are a little bit tricky because there are a number of couple of different types. Service objects can be cluster IP, which means they're accessible internally within the Kubernetes cluster with a non-routable IP address, or they can be load balancer type, which means the Kubernetes API makes an external call to provision an ALB or an NLB. So making sure that the right service type you want to use is the one that you've actually configured. So if there is, for example, a workload that you need to expose an endpoint outside of the cluster, using a load balancer type or a node port would be appropriate, but using a cluster IP service type is not going to cut it for you. Ensuring that the service label selectors match the actual underlying workload pods that back the service objects. That's, and can be a mistake that that can be made where the service exists, but it doesn't have anything behind it to send any traffic to. So you have to make sure that those are in alignment. Additionally, kind of touched on that last point there regarding the cloud platform. You need to make sure that that Kubernetes itself has the appropriate IAM permissions to authenticate with the cloud provider. If Kubernetes does not have permission to provision a load balancer, every time it tries to provision one, it's going to fail. So that's one of those last items you need to make sure is appropriately configured. In this case, using infrastructure as code, Terraform or CloudFormation is extremely helpful.
I think now we are going to talk about DataSet and Kubernetes Explorer. But before we do, I want to show you. So there are a few things that we're going to do. So we're going to talk about different EKS implementations, right? So on EC2 and Fargate that Josh mentioned. So let me show you what I have deployed here and how you can, when to use which, right? So here I have deployed a 3-node EKS cluster, very simple. So there are 3 ways basically to do EKS. So one is a static number of nodes, right? No auto scaling. So you can say I need 3-node cluster and that's it, right? The other thing you could do is you can manage your own EC2 environment, but with auto scaling. So this is what I'm saying here. So start my cluster at minimum size 3, and it can maximum size you could do 5 or however many that you would need here. You can use for stateless application specifically, you can specify this field to get spot instances. So as you know, spot instances are very cost effective in comparison to on-demand instances. So you can use spot instances within EKS cluster. You can tell instance types and when to start and how much percentage on the base to auto scale. So this is auto scaling with EKS. You can also say managed nodes, managed node groups. So in this case, EKS will manage all the infrastructure for you. And finally, the third one is Fargate. So to start EKS for using Fargate is just this one Fargate profile. So anytime I'm going to schedule a workload, a deployment or service or anything pod, anything I'm going to put in FP dev, that will run under Fargate. So that will not run under my EC2 instances. So when to choose which, right? So remember that you do not have the concept of a node because Fargate is serverless in EKS Fargate. So anything that you are running as daemon set, which runs on node, will not be available. We also make sure that EKS Fargate is available in the region that you want to run. If you have workloads that scale up or scale down massively, then this is probably the best way to run those workloads. And the benefit would be you do not pay anything for the infrastructure. You pay only on the consumption basis, the CPU, the memory, the duration of your workload. So you can choose different flavors of EKS under different use cases and different workloads. So going back 2 slides, and we're going to take a look at in the demo different troubleshooting scenarios that Dave was mentioning. So let's talk about DataSet. We have not talked about DataSet till now. So DataSet is the backend log management event backend platform for SailOne. So SailOne is a leader in cybersecurity space, so EDR and XDR products. And they were looking for to scale their backend platform. So they were looking for different solutions. So they found a company called Scalar, and they ended up acquiring a Scalar because Scalar is, which we rebranded as DataSet. And it is a cloud-native log management solution, event data platform that can scale effortlessly to petabyte scale. And this has now become the backend for SNL1, like trillions of events, 24/7, 365 for SNL1. So it can handle all the scale that comes from cloud-native distributed infrastructure. So let's take a look at how we deliver effortless scalability, real-time performance, as well as lowest total cost of ownership, which is very important. Like the cost is important, specifically as you're considering Kubernetes implementation at scale, because as we saw, enabling audit logging and just getting data from different components in Kubernetes is going to explode your log data volume. So you not only need blazing fast query performance, pretty much limitless scalability, but also doing that at a lower cost. And the founders of the Scalar, which is now we rebranded as DataSet, they came from Google, which Steve Newman, they wrote Google Docs and later Google Drive. So think of this is the unique challenge that they were facing. Google Docs is a free offer, amazing scale. So they had to solve this challenge of delivering at scale with the real-time performance, but at a lower cost. And this architecture is trying to answer that question. So how do we do that? So on the left-hand side, the way to read this slide is from left to right. On the left-hand side, I'm showing different data sources, be it Lambda or serverless environments, containers, Kubernetes, multi-cloud, your EDR, XDR data, or security-related data, IoT devices, or your applications. And we can get this data. We provide complete flexibility to get this data to DataSet. So we have an agent, specifically for Kubernetes, we have an agent that runs as a daemon set, which collects data from the kubelet, from the node itself, API server, as well as your application data. The entire platform is available using API. So you can ingest data or you can retrieve your data. We have log shippers like Logstash or Fluentd. So you can use that to ingest data in other circumstances, right, to DataSet. And we have a Kafka collector. So if you have built a pipeline, when data is sent to Kafka and from there it is routed to different places, we can collect data from Kafka deployments. And then we provide, RBAC capabilities. The data can be parsed. Specifically in Kubernetes environments, is JSON. So it is looking at all the fields. That is, you can easily search very quickly on those fields. But also data can remain as a raw file of the data. You can write rules on data redaction. So if there is any personally identified information or any sensitive data, you can redact before entering into DataSet. And you can also cost attribute data to different teams, different applications, and different groups. Now, but the real magic happens when data enters in DataSet. So I talked about the three challenges that we have to solve, right? The scalability and cost and performance. So we use Amazon S3, right, object storage to store data. And you cannot beat the cost and scalability aspects of object storage systems such as S3. Practically unlimited scale and at a lower cost. So we solve that problem. But what happens is when you're retrieving data from S3, performance is not real time. So this is the magic sauce that we built, a massively parallel query engine. So just like Google search, when you execute a search, the entire cluster is executing your search. Here we are dedicating every single core of every compute instance to fetch that data. That's from using the columnar data format. So your 96% of our queries return within 1 second. So your queries are super fast. and the queries which are repeatable, the queries which are powering the dashboards or alerts or certain conditions that you have put in, those queries are going through our summary service, the streaming engine. And that streaming engine also sends data to Livetail. So you can Livetail your logs and look at everything in real time. So that is dataset architecture in a nutshell, but basically it delivers on performance, scale, and the lowest total cost of ownership. So let's take a look at Kubernetes Explorer. So this is a Kubernetes specific solution that we have built. This will do automatically Kubernetes logging and monitoring. So it has a one-step Helm installation. You install the daemon set with all the configuration using Helm. It gives you full stack visibility, so your nodes, pods, containers, and workloads. We have pre-built dashboards so that you get fast time to value. You can navigate between different components in your Kubernetes environment. You can give access to developers. We will have different developers, different teams trying to access, so you can ensure that which logs can be read or consumed by different teams. And I talked about the lowest TCO. Just it is very important in Kubernetes specifically because it's just the data volume is high, and traditional solutions will be very expensive here. So with this, let's take a look at the demo. So here, first of all, I want to show you, this is the dataset platform. So you can run any full text, free text format, any query that you want, and you can appreciate the performance on this. So I could run something like blah or error, whatever I'm searching, and it is going to search through millions and millions and millions of logs. And you saw just, free text error message, it came within, just a couple of seconds. And it searched more than 1 million, right? Almost 2 million events which contained error. So all of your developers, DevOps teams, but the searches that they're performing will be very, very, very fast. Specifically talking about Kubernetes Navigator. So let's take a look at this, right? So this is what we have built for Kubernetes. So this is giving visibility into entirety of clusters. So I have 2 clusters running. This is the dataset demo cluster that I created within EKS environment. So you can see here is a 3-node cluster, and on which dataset is running as a daemon set. So it will tell you how many nodes, and this is just by looking at this, you can see which nodes is performing hot, right? Just the heat map. You can look at how many pods are running per cluster, how many containers are running, and then you can navigate to a little bit granular on nodes, or nodes that are how much CPU is consumption they're consuming, or memory. So performance characteristics such as memory, CPU, disk, network. So that is given by default. And you can customize these dashboards to your liking. Now, the interesting thing is your workloads. So I have deployed here. It gives you, again, complete visibility into your workloads that are running across the cluster. You can obviously search through the cluster, or you can search through the workload type or workload name. So here I'm showing different workloads deployed here in my cluster. For example, Dave talked about field scheduling. So I have deployed a cron job. I'm calling it hungry job on my cluster. And what I ended up doing is I am asking Kubernetes to schedule this cron job, whose job is to basically wake up every minute and say hello from Kubernetes cluster. But to simulate the error, I'm saying, hey, give me 48 cores. So my 3-node cluster with the T3 large instances, it does not have 48 core or 32 gigs of memory. So it should fail, right? It should not, Kubernetes will not be able to schedule. So usually it will be like digging through logs, but we have made it really simple. In a couple of mouse clicks, you can see this is the workload detail panel. So here you are seeing what is the workload that we are trying to deploy. This is the cron job. It says fill scheduling, and it is giving the error message right here. So 0 of 3 nodes are available, 3 insufficient CPU, 3 insufficient memory. So, so any error of this type can immediately be surfaced using this. Going back, you can look at, for example, this email service. It is telling you, hey, replicas, I'm expecting one replica, but I do not have one replica. So there's no replica running. So there's something wrong, right? So it has the status of backoff. So backoff is happening. So you can click on this. It will tell us backoff restarting failed container. So there's a container, it starts, it fails, it's trying to restart again. And this is backoff happening. From here, I want to know more. So you can click and it will give you the contextual logs coming from that application. So you can see that, hey, there's this application that is being created. And as soon as the pod starts, there is an application error. You can take a look at these logs and fix that application issue that you have. So within a couple of mouse clicks, you can get from overall picture what is happening in the cluster to particular workload, and going to granular logs on why this exactly is happening and how to fix that out. So I think this is all we have for the content that we have prepared. You can, take a look at a couple of content that we have created for you. So you can look at this ebook, which talks about these different failure scenarios in Kubernetes and how do you troubleshoot it. Also, DataSet is free to try. So free 30-day trial, fully featured, that you can try yourself and deploy our daemon set and start getting event data, Kubernetes log data into DataSet and see troubleshoot any issues that you have. With that, let's see if we have any questions. Cody, do you have any questions?
Yeah, we've got quite a few questions, so we'll just take them from the top. So how do you manage the proliferation of container images?
Dave, do you want to take that?
Yeah, definitely. So one of the things that we do is implement a specific approach for how to use ECR, and then just ensure that, as I said, because that's what we use as our container registry, and then ensure that that structure is in place and follow that with the various engineering and operations teams. So what do I mean by that? I mean ECR has lifecycle rules in place to clean up, to purge old images based on like number of images total or duration. So for a particular registry, anything past like 30 days. So we use those rules specifically with high churn ECR registries, which have multiple images posted to them multiple times a day, and then if there are any kind of like long-standing, long-running images that need to stick around, for example, that might need to be published more than like 30 days in the future. Those are published to different registries with more conservative lifecycle rules.
Great, thank you for that. Our next question reads, how do you scale stateful applications such as databases?
I think I can take that one.
Yeah.
Yeah. So assuming we're talking about on UKS, we talked about it a little bit, but there are those AWS controllers for Kubernetes or ACK. And so generally the idea there is that you're not managing things like databases on clusters. You're using our fully managed offerings like RDS, and you can just create them and manage them from within the cluster within your applications.
Yeah. So Kubernetes, right? So amazing for stateless applications, stateful applications, specifically databases, which are active, passive. In that topology is difficult to scale in Kubernetes environment. Distributed databases like Cassandra, right? There's a Kubernetes operator that's been run by many organizations. But like MySQL, my advice would be to use a managed database, and ACK that Josh was mentioning. Why would you want to use database in the Kubernetes, right? So it will give you the control on the life cycle. So this is a great sort of compromise or great solution to running databases like MySQL or Aurora or any other RDS flavor on your Kubernetes using ACK from AWS.
Great, thank you both. So this next question reads, we use Splunk as log management for all use cases. Can we use DataSet alongside Splunk?
I think that's a great question. Splunk is a very powerful log management solution, and they have a lot of lot of companies are using it. I came from Splunk. So answer is yes. You would find Splunk, which was performing really well for traditional applications, where you are generating hundreds of gigs or even some terabyte of data. But if you start using Kubernetes successfully at scale in production, and you enable things like audit logging so that you have visibility into every single event, you would find that solutions like Splunk, Elasticsearch, they will run into scalability issues. Plus, definitely the expense, right? The cost is really high to run these sort of workloads on, or these sort of deployments on Splunk. So DataSet, as I mentioned, this will give you the lowest total cost of ownership, which is especially important for when you're running Kubernetes at scale, real-time performance, and can scale to petabytes of data for you effortlessly. Specifically, if you want to run a Splunk and DataSet side by side, so we have a Splunk base app, which gives you the ability to query data from DataSet within your Splunk environment. So you can write SPL-like queries from within a Splunk, so you don't have to even go out of Splunk and fetch data from DataSet, so you can use your dashboards or alerts from within a Splunk if you want to. You can send, so Splunk has something called Splunk Connect for Kubernetes. You can send data from SCK to DataSet, and you don't have to leave a Splunk environment if you want to run both of them side by side.
Well, thank you so much, Amit. And Dave and Josh, thank you so much for joining us as well. We are at the top of the hour, so any of the questions that we received throughout today's program, we will send over to our speakers, and they'll be able to address those after the fact. Josh, Amit, and Dave, I did want to just give you the floor one last time if there was anything you wanted to leave our audience with before we go off the air.
No, that's it. Thank you again for joining us, and let's keep this conversation going.
Yeah, thank you, everyone.
Thanks a lot.
Awesome. So to our audience, just a quick reminder that this session was recorded. You should be receiving an email with a link to access that recording on demand. or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So at the top of the hour, I promised we'd be giving away 4 $25 Amazon gift cards. So our 4 winners are Jack T, Jesse G, Hector L, and Augustine C. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you don't happen to see that email, do check your spam folder. And I would like to give a huge shout out to DataSet for sponsoring today's program. And to our audience, thank you so much for joining us. We really appreciate the time that you take to come and join us on Techstrong Learning. So we do just want to ask for one extra moment for a survey that will pop up as soon as we close out. Otherwise, we hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, everyone.